Welcome back, Mindsetters. If you have just joined us, we are busy with trigonometry for grade 10s with Dina. It has been an absolutely amazing show till now. So if in case you know someone who struggles with trigonometry, or if you know someone who really loves trigonometry, please tell them to join us right now because it is still going to be really awesome. Over to you, Dina.
Thanks, Katlego. Right, everybody. We were working with finding the angle, and I've got one or two more to work with. But I know some of the questions that were posted revolved around the issue of decimal places. Do we always round off to 2 decimal places if we're not told? Well, decimal places are one of those things that have got a very practical value in life. So if you're doing technical subjects, if you're doing measuring, if you're doing architecture or engineering, or any of those subjects that require you to do with real life scenarios, you would really be informed by the context that you were working in, what the decimal places were relevant. So let's say even if you were a doctor, an anesthetist, and you were injecting a patient with some kind of liquid, and you said, must I inject 2 decimal places or must I inject to no decimal places? Well, that's saving a life when you're dealing with medication. So you would probably try and work with that context to determine how many decimal places in order to save the patient's life. So the context always dictates how many decimal places. In maths, with sides, if we're not told, then yes, we often do 2 decimals because the exam is asking us for 2 decimal places. But in life, it's always the context that really does guide us and govern exactly how we are going to do. So today I'm using 2 decimal places. However, I'm not too mad about angles with 2 decimal places, because if you look on your protractors, you'll notice that you cannot measure an angle 2 decimal places. You can maybe measure it to 1 decimal place, but it's very difficult with your protractors to actually measure to 2. So an angle is quite okay to measure to 1 decimal place in our theoretical context, because we're doing theory here. We're not using a practical context. So always, mathematics is a useful tool for practicalities, for context that involved calculations, and always be governed by the context to determine the number of decimal places. There's another question that was posted on identities. When working with an identity, what do you work with first? An identity is something that, it's a statement that can be proved true in most cases, and sometimes you're given a mixture of ratios to work with, and the first thing that you try and do is either work with your square ratios to make them one term, and the other thing that you try and do is try and get everything in terms of sine and cos, because out of the 6 ratios, you can write 4 of them in terms of sine and cos. Or actually you can write 6 of them in terms of sine and cos. So that would reduce the amount of algebra that you're doing. And then it's a matter of persevering. It's a lot of algebra when you're dealing with identities. So yeah, you just need to persevere once you've established all your ratios in terms of sine and cos. Right, let's get back to the angles. We're trying to find this angle over here, and we are given this side and this side, and my question is the 13 the adjacent side, or is it something else? Well, the 13 is opposite the right angle, so the 13 is the hypotenuse. So therefore, we could be working with either sine or cos, because they both have an hypotenuse in them. But then I notice that I've got the 7,5, which is directly opposite to the angle. So therefore, it's the opposite and the hypotenuse that I'm working with. The moment you've ticked 2 things, that's the ratio that you're using. So we have sine alpha is equal to opposite over hypotenuse, and so we can go and find the angle. Finding the angle means it's our yellow function, and we want the fraction 7.5 over 13, and we've got a 35,23. Right, and then we've got, I think, 2 more to go. So we've got alpha, and we've got this side, and we've got that side. Question, is this side here adjacent? No, it's opposite the right angle, so it's my hypotenuse. And this side here is the opposite. So again, sine alpha is equal to 1,7 over 2,2. So we get an angle of what? Let's see. Remember, yellow function to find angle. It's a fraction, so it's 1 comma 7 over 2.2. And we've got 50 comma 60. So alpha is 50 comma 60 degrees. Remember the unit, it's a degree that you're working with. Okay, let me go on to working with angles but in a different context. Let's look here, solve for the angle. Okay, here we're still solving for the angle. One of the questions that was posted on the Facebook page was around, will we always be given a right angle triangle? Now, the ratio of opposite to hypotenuse and adjacent to hypotenuse and opposite over adjacent will only ever work in a right angle triangle. So yes, to the person who posted the question, you have to work with a right angle triangle. However, trigonometry is not bound just by the right angle triangle. You're going to see next year in grade 11 where you're going to work with angles that are larger, or let's say triangles that are obtuse angled, and you'd like to find some of the sides and angles, and then there'll be other tools that will help you to find that. For now, in grade 10, we do work with the right angle triangle, and I'm going to show you in the next segment how the Cartesian plane assists when angles are larger than 90 degrees. So, yeah, it is a right angle triangle if you're working with SOHCAHTOA. Right, here we've got an equation, cos theta over 3 is equal to 0,102, and we need to find the angle. Now, this is what we'd call a trig equation because we're solving for the angle and we have an equal sign there. Now, whenever solving for the angle, as we saw in these questions over here, was that in solving for the angle, this coefficient over here is 1. There are no terms added, and it's over 1. So coefficient must be 1, denominator must be 1. In other words, this sign ratio must be isolated before we can find the angle. So before we go to our calculator, the sign ratio has to be isolated. So this 3, this fraction, this coefficient of 3, or actually a third, is in the way. We've got to get rid of it. So we need to take it over and say that cos theta is actually equal to 3 times 0,102. Now that we've isolated the ratio, we are able to use the calculator to help us find theta. And so, since it's an angle that we're finding, we need the angle button, which is that button, and we have a 3 times a 0.102. And the calculator will now just give us what that angle is, which is 72,18 degrees, or if we're rounding it off to 1, as we said earlier, which is a lot more convenient, it would be 72,2. But if probably you were using a technical drawing to try and make it absolutely accurate, maybe they'll even ask you to round it off to the 3rd decimal place, because you don't want buildings to collapse. So your decimal places are governed, again, as I said, by the context. So 72,2 will be good enough for our context. So that would be theta equals 72,2. It's an angle that you're finding. Remember the degrees. And as you see, I do not show any symbols, any minus ones. That's how the calculator operates. Your job is to go from the ratio to the angle without showing anything else. Okay, but you need to isolate that ratio first. Right, here we've got root 3 times sine A equals 0,785. And whereas earlier we had a denominator, now we have this ratio over here, or actually this coefficient, which is in the way. So we need to isolate sine A by taking that over and dividing both sides by root 3. So it's 0,785 divided by root 3. And now I know that my calculator is going to give me the angle, so I must just go to my calculator. And we would like the angle using the sine ratio, so it's my yellow button. And we've got a 0.785 that we're dividing by the root of 3. And we want to bracket that. And that gives us an angle A of 26,95. So this 5/500 is going to make that up to the next angle. So let's say 27 degrees. 27,0 degrees. Okay, that just indicates that 0 just indicates it's not 27 on the dot. It's actually, I've rounded off that tenths to the nearest tenth. Okay, then I've got a tan A plus a 5,62 is equal to a 13,256. As we said earlier, I have to isolate this. And I isolate that in the same way as you would isolate an X, as you would isolate an A in any equation. If there are terms, I isolate it by getting rid of the terms and then isolate the coefficients. So here I've got this term that I need to get rid of. So therefore tan A would be equal to 13,256 minus 5,62. So in the end, I'm only looking at tan A. So I've isolated, take the terms across and leave only the trig ratio by itself. If I cannot isolate that tan, I can't use the calculator. The calculator is that last step that you're working to find the angle once the trig ratio is isolated. So we've got this ratio over here. So we can actually say that I want to find the angle. We can do this in one, because we can say that 13,256 minus the 5.62, I can actually do as a unit, and the calculator will give you the angle straight away. So that A is 82,5. Okay. $82,5. Okay, so that was A equals 82,5. Okay, then our last question for the section was, how do you deal with reciprocals? Because there's grade 10s, you working with those reciprocal ratios. So we need to treat them a little bit differently, but the main job is the same with any equation. Isolate that unknown. So we've got sec A is equal to 6,457 divided by 2. Can you see I've now isolated that? Once I've gotten to that step, I'm now ready to say, but if I take the reciprocal of sec, the reciprocal of sec is cos A. So my yellow process is to take the reciprocal. Now, if I do that on the left, I'm going to do that on the right. So my reciprocal is going to be equal to 2 over 6,457. Okay? And once this cos A is now isolated, I can now use the calculator to go and find out what A is. And I think that I've lost the calculator, so we'll take a break.
Let's take a break, okay? So you guys find your calculators so that you guys can help us out. Maybe during the break, you could maybe just finish off the questions and get whatever you need to get straight in your mind, just so that you can ask us questions, because this is actually the perfect time for you to ask any questions that you wish to ask. See you now.